So welcome guys. Let's consider the next subtopic, which is inverse of matrices. Um, for inverse of matrix, we need to consider two things. We can actually find the inverse of a 2 by 2 matrix and inverse of a 3 by 3 matrix and some higher matrix. But for a level, you can only be asked to find inverse of this matrix. For the sake of objective, nobody will ask this from you because this will surely take your time. Inverse of 3 by 3 matrix will surely take your time. So now listen to this carefully. You can only find inverse of a square matrix. Please take note of that. You can only find inverse of a square matrix. Like, what if I give you a question? Let's say A is 1, 2, 4, 5, 3, 6. This is a 2 by 3 matrix. And if I give you this kind of matrix and I ask to find A inverse, just know that the answer does not what? The answer does not exist. It does not exist. Please take note. So you can only find the inverse of a what? Of a square matrix, either 2 by 2, 3 by 3, 4 by 4, and some other dimensions which are square matrix. Now, there are two different ways. You can actually find an inverse of 2 by 2 matrix. If you want to find inverse of this matrix now, which says given A to be 2, 3, minus 1, 4. If you want to find the inverse of this matrix, by formula, we believe that A inverse is always equals to 1 over determinant of that matrix given to you times the adjoint of that matrix. Remember that I've explained adjoint of a matrix. Adjoint, when I told you that you have to swap the left to right diagonal, but you have to leave this one, but you can only change their signs. I think that was my explanation for that. So in this case, you should have something like this. A inverse will now be equals to 1 over the determinant of 2, 3, minus 1, 4 times the adjoint. What is the adjoint of that matrix? That is, I'll swap the left to right diagonal. That means I will have 4 here, then I have 2 here. I'll leave this one the way it is. I'll leave it as 3 and minus 1. So whatever I have left now should be, you change this one to the opposite sign. If you have minus, you change to plus. If you have plus, you change to minus. So that means now I have something of this nature. I have my A inverse now to be equals to 1 over the determinant of 2, 3 minus 1, 4, 2, 3 minus 1, 4 times the adjoint I have 4, 2, 1 minus 3. So this is the adjoint, this is the determinant. And I've explained how to find determinant. Just put a plus and minus sign here and cross multiply. So my A inverse now is equals to 1 over 4 times 2, positive 2 times 4, that's 8. My negative 3 times negative 1, that's plus 3. Times 4 minus 3, 1, 2. So therefore, my final answer for A inverse is 1 over 11 of 4, 1 minus 3, 2. So this is how to find determinant of a 2 by 2 matrix. Please take note. Take for instance, suppose you have another matrix 1, 2, 3, 4. What will be the inverse of this matrix? The inverse of this matrix becomes 1 over, find the determinant of this thing. That is, if you put plus and minus and you cross multiply, you have 4 minus 2 times 6, you have minus 6. Is that clear? Then you find the adjoint. Swap this left right diagonal. This right to left diagonal, you leave it the way it is. 2 and 3. But you change their sign. So therefore, final answer is 1 over minus 2. And that's minus 1 over 2 of 4 minus 2 minus 3, 1. So this is how it works. You can also apply scalar multiplication here because sometimes you might not see this in the option. You might end up seeing something of this nature. 1 over 11 times 4. You might end up seeing 4 over 11. 1 over 11 times minus 3. You might end up seeing minus 3 over 11. And then you can also see 1 over 11 here. And finally with 2 over 11. So when you see something like this, you don't have to be scared. It's still the same thing. This is scalar multiplication, whereby you have just a constant multiplying a matrix. So you can use that constant to multiply each of the digits you have in that matrix. That's scalar multiplication. So that's how it works for 2 by 2. Mostly in JAM question, you can only see 2 by 2. You only see a 2 by 2 matrix, and then you ask to find the inverse. Nobody will give you 3 by 3 and then they will ask you to find the inverse. It's going to take a lot of time Okay, it's going to take a lot of time. Now, let me quickly pick up this one, which is 1 minus 2, 3. 1 minus 2, 3. Okay, matrix B is 1 minus 2, 3. And what again? And I also have minus 4, 2, 1. Let's check. I have 1 minus 3, 4. I have 1 minus 3 and then 4. Now, how do you find the inverse of 3 by 3 matrix? It's still the same process. 1 over, find the determinant of that matrix B, and find the adjoint of matrix B. Now, the problem is, we know how to find the adjoint of a 2 by 2 matrix. Suppose it's just 2 by 2. You know what to do. You swap this. You swap this left to right. You leave this right to left. Now, you can't do that for 3 by 3. How will you swap 1 to 4? There are 6 possible ways to swap this. So, there's no way it can actually work. In this case now, if it is 3 by 3, if you want to find, take note, if you want to find adjoint of B, if you are trying to find adjoint of a matrix, and you notice that that matrix such that the matrix B given to you is a 3 by 3 matrix. If it's a 3 by 3 matrix or 4 by 4. Now, if you now want to find the adjoint, it's totally different too. The way you are going to do it is different. This formula will change to what? Let me show you. This formula here, so this formula you are going to use here becomes this. It becomes cofactor. Find the cofactor of that matrix B and then take the transpose. Transpose of this. That is, I'm saying that if B is a 3 by 3 matrix or 4 by 4 matrix and so on and so forth, then the adjoint of matrix B simply implies that you have to find the cofactor of that matrix B and then take its transpose. So how does it work? Let me show you. So I have to clean this off. You already know the formula to use. So one thing is, I need to find 1 over the determinant of this matrix now. I want to use Saros rule to make it faster. I want to make it of Saros rule. I have 1 minus 4, 1, minus 2, 2, minus 3, 3, 1, 4. So using Saros, you know what to do. Repeat this first and second column. 1 minus 4, 1, minus 2, 2, minus 3. Then leave it that way. Remember that here we have the cofactor of matrix B. Take the transpose. Not C times B. Cofactor of matrix B. Please take note. So I want to try to use Saros rule here. Pick this at the middle. Then you multiply this. What we have? 4 times 3 times minus 4. That's minus 12. And then minus 12 times minus 3. And that will surely give us positive 36. If you multiply this now, you have negative 2. If you multiply this here, you have 8. Sum it all together. That is 36 minus 2. You have 36 minus 2, then plus 8. That should give us 42. Now you have 42 here. The next thing is to do the right to left diagonal. Now 3 times 2 times 1 is 6. 1 times 1 times minus 3 is what? Is minus 3. And then if this multiplies, 4 times 4, 4 times minus 4, that is minus 16. Minus 16 times minus 2, and that is positive 32. So by the time we sum this up, we usually have 6 minus 3, then plus 32. That should be 35. So what is the subtraction of this? You know, the determinant of that matrix B now becomes 42 minus the left to right minus right to left. So remember that we are still multiplying by what? By what you have here, which is what? The cofactor of what? Of matrix B. Then you take the transpose. So what is 42 minus 35. 42 minus 35, you know that should give us 7. So you have 1 over 7 times whatever your cofactor is, and then take the transpose. So this is where I'm heading to. You need to understand what cofactor is. Now, to understand cofactor of a matrix, let me quickly explain. I'll need to rewrite this matrix out so that I'll show you how to find cofactor. Okay. Page, and pick another page. Now let's consider page. Okay, you have 1 minus 2, 3. 1 minus 2, 3. We have minus 4, 2, 1. Minus 4, 2, 1. And then finally we have 1 minus 3, 4. 1 minus 3 and 4. So how do you find the cofactor of this matrix? The cofactor of matrix B implies that you want to find, at this position here, you want to find a value that will replace this using the concept of cofactor. This one will no longer be 1 after solving. It changes to another thing entirely. So I'll tell you what it is. You do the same thing here. You give your answer here. Do the same thing with another answer here. This 3 will not be 3 here. So that is just the main thing to do. So we need to fill this box now. And to fill this, you need to follow these steps. Now listen attentively. One thing you have to do here now is you have to put a sign here. Remember that we used to put plus, minus, plus for determinant, then you stop. But for cofactor, you not stop there. You have to continue. Plus, minus, plus, minus, plus, minus, like that, yeah. So in order for you not to get confused, let me just clear this off. To clear this, to clarify this now, this is what we are going to do. You write out the cofactor of 1. I'm writing cof now. Let me write it very well. So I want to find the cofactor of this position 1. So you write cof 1. Cofactor of 1 is what? I don't know. You need to find the cofactor of minus 2. In that order. Cofactor of what? 3. Cofactor of what? Minus 4. Cofactor of what? 2. Like that, in that order. Then cofactor of 1. Cofactor of another 1. Cofactor of minus 3. And then cofactor of what? 4. Now let's pick this first one. You know, I put some signs here. So those signs, this is where I want to put it. Plus, you know, there's a plus, minus, plus here. Put a plus, minus, plus, minus, plus, minus, plus, minus, plus. So at this position, whatever you have left now is a determinant, which is cross this out, cross this out. What do you have left? 2, 1, minus 3, 4. Do the same thing for this one also. For this cofactor of minus 2, drag it out, cross this out, cross this out. What do you have left? Minus 4, 1, 1, 4, right? Go ahead. For this position 3, cross it out, you have minus 4, 2, minus 4, 2, 1, minus 3. So that's how you do for the rest of them. You do for this one also. So I may not solve this finish. You can try to finish that. So that's why I say you can't see this kind of question in your exam. Surely take your time. There are other advanced shortcuts that you can use, but not for your level. So in this case, you want to find the determinant of this. Put a plus, minus, and a cross multiply. Plus, minus, and a cross multiply. So you know what this will give you. There's positive sign here. By the time you cross multiply, you have 8 plus 3, and that's 11. Do the same thing for this one, plus, minus, and then you cross multiply. This is minus 16, minus 1, and that's minus 17. Very good. This one, what of this one? Cross multiply, plus, minus. You have plus 12, minus 2, and that's 10. Here you have minus 16, minus 1, that's minus 17, times this minus, you know, there's a negative sign outside, so that becomes plus. Please take note of this. This becomes plus, and this is minus 12 plus 12 minus 2, that's 10. So you do the same thing for this one also. This result that you now have here are what you fill in this box. Do you understand our logic now? Cofactor of 1, instead of writing 1 now, after finding the cofactor, I have 11. After finding the cofactor of this minus 2, in replace I have what? 17. In replace I have what? 10. So let's say you have 5, you have 2, you have 1, you have this. So this is the cofactor. But remember that the adjoint says that you have to find the cofactor of that matrix B and then take the transpose. So you need to take the transpose, and I've explained transpose. Turn this one to vertical, and then that's how it works.